Hello, fourth graders. I'm going to go through this review quickly with you and use my notes, the way that I'm solving these problems, as a way to help you solve any of the problems that were confusing to you. If after you've watched me solve any of these problems, you are still confused, you have no idea what's going on, which won't happen because we've worked really hard on this, just circle it in red and we will talk about it one-on-one, okay? The first thing we're going to look at is conversions. Here, I want to go from 5 meters to centimeters. I'm going to use my conversion chart because you're going to have this with you when you are taking the test and doing the review. So I want to look and see how many meters, or how many centimeters rather, is in a meter. I look over here and I find it. I know that there are 100 centimeters in 1 meter. So if I have 5 meters and each one has 100 centimeters, I know that I can multiply. Because I'm going to take my 100 centimeters, because there's 100 in each one, times 5, and multiply. I get 500. So I have 500 centimeters. 8 centimeters to millimeters. I know from looking at my handy dandy conversion chart that there is 1 centimeter in 10 millimeters. So I'm going to do 10 millimeters times the 8 centimeters that I have, and I will get 80 millimeters. I want to go from yards to feet. I look over here. In 1 yard, I have 3 feet. I have 3 yards. Here I have 3 yards, so I have 1 yard, 2 yards, 3 yards, 1 set of 3 feet, 2 sets of 3 feet, 3 sets of 3 feet. 3 sets of 3 feet. 3 times 3, we should know these math facts, 9. So 3 yards, 3 sets of 3, 9 feet. If I want to go from feet to inches, I know this without even looking at my conversion chart, that I have 12 inches in every foot. Now I have 5 feet. 5 feet, 1, 2, 3, 4, 5. 12 inches, 12 inches, 12 inches, 12 inches, and then 12 inches, okay? 12 inches in every foot, 12 times 5. 2 times 5 is 10. I write my 0 down here because there's no 1s. I carry my 10 to the tens place. 1 times 5 is 5 plus 1, my extra 10, and I have 6, so 60 inches. Okay? The next problem is asking me to draw this shape so that it's symmetrical. This line right in the middle is our line of symmetry. So I want to start here at this line, and I want to do the opposite. I want to be able to fold this over, this shape, and not have any weirdo pieces sticking out. So I'm going to start here. Here where it goes to the left, I'm going to go to the right. Here where it goes kind of diagonal down to the left, I'm going to go diagonal down to the right. And I'm going to follow the shape to the best of my ability and make a mirror image. So again, if I were to fold this over, I would have no pieces sticking out, okay? Down here, I have to circle the 2 statements. Oh my goodness, don't get points off for only circling 1. The 2 statements that are true. The first statement says, a right angle makes a square corner. Now we know what a right angle looks like. Let me erase this here so we have some space. Right angle looks like this. 2 perpendicular lines coming together. And a square corner means that this corner looks like the corner of a square. I should be able to do the paper test here. If I took a piece of paper and put it here, would it line up perfectly for a right angle? The answer is yes, so I circle that one. An obtuse angle is more closed than an acute angle. So I know for obtuse, I think, bump, 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 we have the meat's fat. Big fat angle. Acute is, oh, it's just so cute. It's little. It's just a baby. So I know right away that my obtuse angle cannot be more closed than my acute angle. It's just so cute. So I'm not going to hit that one. An acute angle makes a square corner. Now wait a minute. I've already decided that a right angle makes a square corner. So I know that an acute angle cannot make a square corner because it's just little. Okay? All right angles have the same measurement. Well, all right angles are 90 degrees, so that must also be true. Last question on this page it asked me to draw a line of symmetry. So I want to draw a line on this shape, on this polygon, where I could fold it on that line and no pieces would stick out. There are lots of options here because it's a wonderful, beautiful star. I'm going to do the easiest option. I'm going to start right at this top point and do my dotted lines down, because if I were to fold it over this way, perfectly matched. Okay, so that is the end of page 1. Hopefully you were successful and didn't even need my help, but if you did, I'm always here for you.